Hello, Salman. Umaid, can you hear me? Hello, Umaid, can you hear me?
Yes, sir.
Just a second. So we're gonna try and do this past paper. Just a second. TK it's S21 QP13. So starting with this paper, and we're gonna try and do the organic. We're gonna try and do it in reverse. Try and do the organic first. ठीक है बल्कि एक just 1 second. So we start कर लेते हैं starting with this question. रियान आवाज आ रही है ना?
जी सर आ रही.
अच्छा, so starting with this question, ये वाला कर लेते हैं कि 5-hydroxypentanoic acid is readily converted into the cyclic compound L. ठीक है, L क्या चीज है? L is an ester. ठीक है, ये जो this thing over here, that's अच्छा, so this thing over here, that's an ester. ये जो पूरा चीज बना हुआ है, ठीक है, C double bond O and O. That's what an ester is. So which statement about its reactions are correct? First one, sorry, first thing is 5-hydroxypentanoic acid is converted into this thing. Okay, so what is 5-hydroxypentanoic acid? So pentanoic acid is 5 carbon atoms, and pentanoic acid is double bond OH. 5-hydroxy का मतलब है कि जो end वाला OH है ना, the last one, ठीक है, that has an alcohol, ठीक है, 5-hydroxy. And then you have the rest are all H atoms, ठीक है, so you've got H, ठीक है, सारे H है. So now what's happening is, in this case, what's happening is the ends are the ones that are connecting with each other. So this alcohol reacts with this carboxylic acid and they bond together and they form, when an alcohol and an ester bond, they form an ester. Okay, so this is what happened. 5 carbon atoms. So the 5 carbon atoms in a cyclic structure, they ended up forming an ester. So this thing got converted into this thing. So which statement about this reaction are correct? So this is esterification. Okay, how are esters formed? So esters, whenever esters are formed, dichromate 6 has nothing to do with it. So the first option is wrong. A water molecule is produced. So that is what happens in alcohol when a carboxylic acid reacts with it. They form an ester. A water molecule is a condensation reaction. And concentrated sulfuric acid is the reagent. Esters form karne mein, that is definitely your reagent in this reaction. Okay. I said next is now the next thing. Okay, you've got I said the next thing is okay, there are 3 molecules. Which statement about X, Y, and Z are correct? The first one over here, that's a ketone. That's 2 carbons on one side. Then you've got a double bond O, and then you've got a CH3. So that's a carbon on the right. This one is 2 carbons on the left side. Then you have a carbon, and you have a double bond. You have an aldehyde. Okay, so that's an aldehyde. And the last one is a carboxylic acid. ठीक है, इसका 3 H's होंगे. This one will have 2 H's, 3 H's, 3 H's with this, 2 H's, 3 H's. As anyways, X reacts with alkaline aquasidine. So the question is, what is alkaline aquasidine? So let me open the organic chart. So this one, iodoform test, alkaline aqueous iodine. Just a second. So alkaline aqueous iodine is this reaction. It's known as the so this one is known as the iodoform test. Okay, iodoform test tha कि you've got remember this is the division chart. Okay, so you need a methyl with a acetyl bond or you need a methyl with CHOH. Okay, so you have this iodoform test where the CH3 breaks off and it forms a yellow precipitate and the other carbon turns into a carboxylic acid. Alkaline conditions होती हैं तो वो फिर salt बना लेता है. So anyways, you need these two structures for the iodoform test to be positive. So यहाँ पे which one has it? It's got to have a methyl. I mean, this one has it. What you need is you need a methyl with acetyl bond O. Okay, so this one will have a positive iodoform test. This one is the X reacts with alkaline aquasidine. So that's right. Okay, it does have methyl with acetyl bond, double bond O. Okay, iodoform test ke liye that's important. Methyl with acetyl bond O. Next one. Y reacts with Tollens reagent. So this one is an aldehyde. So does it react with Tollens reagent or not? So aldehyde जो होता है वो दोबारा go to the chart. ठीक है. So primary alcohol will turn into an aldehyde and it will then further get oxidized to a carboxylic acid. So how does an aldehyde turn into a carboxylic acid? Tollens reagent. Okay, that is used. It produces a black precipitate and silver mirrors. So aldehyde gets converted into a carboxylic acid. So Y reacts. Y is an aldehyde. So Y does react with Tollens reagent. Okay, so पहली दोनों statement correct है. Z does not react with alkaline aquasidine. So Z will not react. You need a methyl with a C double bond O. क्या था उसके लिए? What you needed was for the iodoform test to be positive, you needed a methyl with a C double bond O, not a carboxylic acid. Okay, it was methyl with a carbonyl group. Remember, R is a carbon chain. Okay, so यहाँ पे the last option that's incorrect. Okay, over here you have a methyl, but not with a C double bond O. You have it with a carboxylic acid. So alkaline aqueous iodine वाला जो test होगा ना, that's going to be wrong. तो ये 39 ये clear है ये वाला?
जी सर.
अच्छा, फिर ये कि bromo-ethane reacts with NaOH in different ways depending on the solvent used, which was about these reactions are correct. So halogenoalkane, ठीक है? So halogenoalkane के दो reactions हैं. One of them is substitution. What happens is if you have a halogenoalkane, the OH आएगा उसको halogen को substitute करते हैं. It will turn into an alcohol. That's one. For that you need NaOH aqueous. Halogenoalkane का ही एक और reaction है where you have NaOH and it's ethanolic, तो वो alkene बन जाता है. वो halogen हटता है, वहाँ पे double bond आ जाता है. So you got two options. Either you put a double bond and you turn it into an alkene, or the halogen gets replaced. दोनों में बस solvent का फर्क है. One of them is NaOH aqueous, the other one is NaOH ethanolic. So going back to the question, if you use the solvent as water aqueous, bromoethane is this thing. It's 2 carbon atoms and with a bromine. And the rest are all H atoms. Achha, agar water is used as a solvent, NaOH aqueous, Br will go away and OH aa jayega. So it will form ethanol, not ethane. Ethane 1,2-diol nahi hoga. Do OH groups nahi honge. The second one is if you use ethanolic NaOH. तो फिर Br हटेगा, वहां पे डबल बॉन्ड आ जाएगा. It will actually form an alkene, and that's going to be ethene. So this is correct. और water यूज करोगे तो वो alcohol होगा, OH आ जाएगा. ठीक है. So 2 and 3 are correct. You won't get ethane 1,2 diol. ठीक है, ये भी क्लियर है. और रिमेंबर इसके ऊपर ना बहुत क्वेश्चंस आएंगे कि इसके ऊपर के हैलोजेनो अल्केन्स है, NaOH aqueous यूज किया तो सब्स्टिट्यूशन होती है, it turns into an alcohol, and if you use NaOH ethanolic, it will turn into an alkene. अच्छा, next for which statement each brominated carbon is chiral? Chiral का मतलब 4 different groups attached to it. So it is 4 different. There's going to be 1 H as well with each one of them. तो सारों के साथ एक H होगा. ठीक है. Carbon makes 4 bonds, so all these carbons have 1 H. अच्छा, फिर से रिपीट कर लूं. This is summer 2113. अच्छा, so all of them are chiral. इसके ऊपर अगर आप, if you stand on this, it's all 4 sides are different. Right side पे ये, left side is different. So all 4 sides are different. So all the brominated carbon atoms they are actually chiral. अच्छा, molecular formula C12H वो करना पड़ेगा कि सारों के साथ देखना पड़ेगा कितने H हैं. साथ 2 होंगे. This one will have 2 H's. This one will have, skeletal formula में H count करना मुश्किल होता है. This one will have 2 H's. This one will also have 2 H's. So carbons कितने होंगे? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. अच्छा, so you've got 12 carbons. ठीक है, that's correct. Hydrogens कितने? That's 1, 2, 3, 4, 5, 6. ये हो गए. फिर 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 is fine. So ठीक है, the formula is fine. And all the bond angles are 120 degrees. All of them are 109.5. ये last वाली statement जो ना, that's wrong. 120 degrees नहीं है, क्योंकि कार्बन जब 4 bonds बनाता है ना, it's tetrahedral. It's not actually 120 तब होता है जब वो double bond बनाता है. ठीक है. चलिए, ये clear है question ये वाला?
Yes, sir.
Which statement helps to explain the increase in melting point from sodium to aluminium? Now that's from sodium to aluminium. This is an inorganic question. ठीक है. So sodium to aluminium, if you remember inorganic अभी chart खोल लेते हैं, melting points, right? का inorganic, एक second. Yeah. अच्छा, so you've got, ठीक है, जस्ट रिमेंबर यहाँ पे जो सोडियम है ना, वो थोड़ा सा इधर ऊपर बना हुआ है. It's probably down here. ठीक है. Anyway, sodium, magnesium, aluminum, they're all metallic. ठीक है. All of them are metallic. So why are their melting points increasing? So the reason is they're all metallic bonding. What is metallic bonding? Metallic bonding is positive ions, a regular arrangement of positive ions in a sea of free moving electrons. So यहाँ पे ना बीच में there are lots and lots of delocalized electrons. Now what happens is when you go from Na to Mg to Al, first thing is that the charge on the ion increases. Na is +1, Mg is +2, and Al is actually +3. And then the amount of delocalized electrons also increases. Na can only lose 1 electron, Mg can lose 2 electrons, while aluminium can lose 3 electrons. So you have the same metallic lattice, but you've got more charge on the metal line. That's one. You've got more delocalized electrons, so metallic bonding is going to be stronger. And the third one is also true. The radius of the metal line also decreases. You have smaller ions as well. Why do they have smaller ions? Because when you go to the right of the periodic table, the number of protons increase. I mean, this is 11, this is 12, and this is 13. So you have more protons as well. The more protons ka matlab hai you've got, I mean, they all have the same number of electrons. It's 10 electrons each. I mean, the ions have 10 electrons each. So what happens is that the size of the ion also decreases. So smaller ions, they're closer to each other, they're more packed. So that will also increase the strength of the metallic bond. So all three statements are correct. Okay, Na to Mg to Al, the metallic bonding becomes stronger. More charge in the ion, more delocalized electrons. Plus you have smaller ions as well. Okay, is this clear, this one?
Yes, sir.
Yes, sir.
So then you have this one. This one is which reagent produces a solution of sodium chlorate 5, which is NaClO3. Now it's a typical reaction that you just have to remember. It's about forming bleaches. TK, that's also given in the notes. TK group 17. If you remember this, you'll just know this. Where's group 17? As it's this reaction. In group 17, if you check the notes, you have a disproportionation reaction where chlorine reacts with NaOH to form NaCl, NaClO3, and H2O. And it has to be, if it's hot NaOH, it's going to form NaClO3. If it's cold NaOH, it's going to form sodium chlorate 1. So he's talking about sodium chlorate 5. So it's probably going to be this one. So the answer to this one is chlorine with hot concentrated NaOH, that's true. Not with cold, it's not going to form NaClO3. In cold, it's going to form NaClO. Chlorine dissolved in water is also wrong. It's not going to form. It's not going to form NaClO3. Like if I do chlorine dissolved with, I mean, there's a reaction of chlorine with water as well. That is swimming pools. TK, it's used in swimming pools. Chlorine with water, it forms HCl and HClO. It does not form NaClO3. So you just have to remember this fact, that chlorine with hot concentrated NaOH will produce NaClO3. As the next one, element X is a solid under room conditions. It occurs as a contaminant of fossil fuels. So fossil fuels, it's a fossil fuel contaminant. Probably what's a fossil fuel contaminant? Sulfur is one common contaminant. Its oxide Y is formed when fossil fuels are burned. So I guess that's, I mean, I'm just making guesses, probably sulfur dioxide. In the atmosphere, it can be further oxidized to Z. So it does get oxidized in the atmosphere, it forms sulfur trioxide. So there's an element X, so I guess it's sulfur. So atom of X have unpaired p electrons. They do, as sulfur is in group 6. So if sulfur is in group 6, it's got, what's the outer electronic configuration? It's going to be S2, S2p4. TK, I mean, it's 16 electrons. You can write the whole electronic configuration, but any element that's in group 6, it's going to be S2p4. P4 means that one of the p is going to be paired. So atoms of X have paired p electrons. That is true. At least one of them is paired. The atmospheric oxidation of Y to Z is a catalyzed reaction. That is also true. SO2 turning to SO3. This is how acid rain gets formed. TK, that's also in the notes. Where's acid rain? Where did acid rain go? Just a second. This one. Now in acid rain, what happens is that NO2 oxidizes SO2. SO2 gets oxidized by NO2. That's the other pollutant. And it turns it into SO3. And NO gets reduced. And the NO gets oxidized in the air by itself and forms NO2 back again. So this one is true that it is catalyzed by NO2. So then with water, Z forms a strong acid. It does, because SO3 forms sulfuric acid. So that is also true. So all three statements are correct. You can remember sulfur is a contaminant of fossil fuels. That's also given in the notes. यहाँ पे लिखा होगा कि sulfur is present in fossil fuels such as coals and also present in volcanic ash and volcanic activity. A lot of sulfur dioxide gets produced. Now, so this one, disaccharides are hydrolyzed in slightly acidic conditions. The reaction is very slow. A biological catalyst is added to a slightly acidic mixture of 3 disaccharides, sucrose, maltose, and lactose. The hydrolysis reaction remains slow for sucrose and maltose, but is now much faster for lactose. So basically what he's adding is I mean, the whole thing is not in your syllabus. That's more biology, but he's adding a catalyst, and the reaction speeds up for lactose, but it remains slow for sucrose and maltose. So that means it's acting as a catalyst only for lactose. So the catalyst, I mean, whenever you add a catalyst, you don't increase the activation energy, you actually decrease the activation energy. So, I mean, this statement is true, it's false. The catalyst shows specificity. This thing is biological catalyst. If you remember the lock and key model, enzymes and biological catalysts are very shape specific. So it does show specificity, means that it only acts on some of them, but not on the other ones. So it only acts on a narrow range of substrates. So a biological catalyst over here is showing specificity because it's only acting on lactose, but not on the other two. The hydrolysis of lactose using a catalyst is a different mechanism to the hydrolysis of lactose without a catalyst. So catalyst does change the mechanism. It alters the mechanism. It provides an alternate path. So that is always true for a catalyst. It always creates a different route for the reaction to happen. So the first statement was wrong. It does not increase, it decreases the activation energy. The rest of the two are fine. You can remember biological catalysts are always very specific. They always act on a very narrow range of substrates. They're very shape specific. So if the shape does not match, if the lock and key model does not work, it's not going to work. Now, you will part clear this one.
Yes, sir.
Yes, sir.
So this one, the equation shows the decomposition of 3 moles of an ion containing chromium in an acid solution. What statement are correct? So 1 mole of chromium, 1 mole of CrO3, CrO4. First thing, what is the oxidation state of CrO4 3 minus? TK? So you're always sure about oxygen, it's -2. So Cr is unknown. Oxygen is -2, that's times 4. So the individual oxidation state must add up to be equal to the total charge. So what do you get? What is X now? God, it's -8 and
+5.
+5. As a Cr is +5, can you tell what's the oxidation state of Cr over here?
Sir, it's +6.
Okay, so this one is definitely +6 because 4 oxygens is going to be -8 and you're going to get -2, so it's +6. And then you've got +3 as well. Now, what's happening is Cr is going from +5 to +6. So this is when you have an increase in oxidation state, that's oxidation. And the same Cr is going to +3 as well. So that means there's a decrease in oxidation state. So that's a reduction. So there's reduction happening and there's oxidation. When the same element gets oxidized and reduced at the same time, that's known as disproportionation. Okay, there's a term used. Disproportionation is a redox reaction where the same element is the one that's getting oxidized as well as getting reduced. So Cr is the one that's going from +5 to +6. So how many Crs are going to +6? 2 of them. And how many Crs are going to +3? There's 1 of them. So 1 mole of CrO3 is reduced. That's true because 1 of them gets reduced. So the first statement is correct. 2 of them get oxidized. They change to +6. So that is also true. 3 moles of electrons are transferred. So 3 moles of electrons are transferred. Is that true or not? So how many electrons are transferred? +5 to +6 is how many electrons? 1 electron, right? 1 electron lost. But there are 2 of them. So this will be multiplied by? This will be multiplied by 2. Okay, you're going from +5 to +6. And when you go from +5 to +3, you're gaining 2 electrons. So in total, how many electrons are transferred? It's not 3 moles. It's actually 2 moles of electrons are transferred. 2 moles of electrons are lost and 2 moles of electrons are gained. So the third statement is incorrect. You clear that the third statement is incorrect?
Yes, sir.
Yes.
Okay, next one. Which statement about first ionization energies are correct? The ionization energies are always endothermic. Any ionization energy requires energy to remove electrons. The decreased down group 2, is that true?
Yes, sir. 1 and 2.
Okay. And they don't decrease across the period. Oh, they always increase. There's a dip at 3, then you have increases, then dip, then increases. It increases across the period, generally. So the third one is wrong. Today, organic person. Now this is infrared. Okay. Remember, infrared is simply, what is infrared? That when you have any bond, it vibrates, it absorbs a certain frequency. Any bond. Okay. Like any bond between X and Y, it's going to absorb a certain frequency. And remember, it's a very simple concept, just a very small, short concept. And it absorbs a certain frequency. Okay. These wave numbers are basically frequencies. They're proportional to 1 over lambda, and that's basically frequency. So in this spectrum, which frequency is getting absorbed? It's this one. This is the one that's getting absorbed. So you have an absorption, kind of a strong absorption at EK value. That's 1300 something. 1300 to 1400 wave number. So you have this absorption at 1300 to 1400. So for this, there's going to be a data booklet printed next to it. I'll open the older version of the data booklet. And this one has, an infrared spectrum table somewhere. I guess this one. So anyways, so the question is, here are different bonds and there are different frequencies that are getting absorbed. Now, हमारा जो case था, that was 1300 to 1400. So I guess, is there anything at 1300 to 1400? There's probably nothing there. Everything else has a different range. The closest I can think of, the closest is this one. I mean, this one is kind of close. So probably a C single bond O, probably this one. Okay, because the rest all have different absorption frequencies. So one by one, we're gonna try and eliminate the options. So you're saying, what is the identity of this thing? So it's definitely not a C double bond O. Okay, why is it not a C double bond O? Because if you look at the table, C double bond O जो है ना, वो where does it which frequency does it absorb? It absorbs a frequency at 1600 to 1700. So it's definitely not a C double bond O, because you've got nothing at 1600 to 1700. Look above it, there's no absorption at this range. So definitely not a C double bond O. So eliminate all the C double bond O's. Any molecule that's got C double bond O, that's out of the question, right? So all of those are gone. So what are you left with? You're just left with this last one. So what did I tell you? If I looked at the table, I said that the candidate for this one at 1300 to 1400 was probably C single bond O. That was the one that was the closest we had. Okay, that was the first one. That was the closest we had, which matched our absorption. So it's going to be C single bond O. So I guess it's the last one. It's going to be D, because C single bond O, this is C single bond O, this is C single bond O as well. It's got carbon double bond carbons as well. So where do carbon double bond carbon resonate? So not resonate, where do they absorb frequencies? They have a very weak, W is weak. They have a very weak absorption at 1500 to 1680. But anyways, so there is a weak absorption at 1500 to 1680. There is some small weak absorption at this point. So this one is probably going to be C double bond C. But the question was pretty easy. It was pretty easy because you found out that C double bond O absorbs a frequency at 1600 and you had nothing there. So which eliminated all the three options. You were just left with the last option. Is that clear?
Yes, sir.
Yes.
The infrared spectrum, ठीक है, just remember this. You'll just be able to identify one or two bonds in the whole spectrum. And based on that, you'll be able to figure out what the molecule is. As the next one, question 29, you've got this reaction. There's a carboxylic acid. What happens to a carboxylic acid when it gets reduced? So where's our chart? So carboxylic acid, this is carboxylic acid. Okay, LiLH4 reduces it, it turns into an aldehyde, and that aldehyde will further get reduced by LiLH4 and it will turn back into an alcohol. So primary alcohols are the ones that turn into carboxylic acid. So carboxylic acid turning back, it will turn into a primary alcohol. So this option is, I mean, this is a primary alcohol, so it's going to be option A and B. फिर Q क्या होगा? What's Q? This one is an ester. So let's draw this. It's one carbon atom CH3. And then you have an ester link, C double bond O and O. Then you have another carbon atom and two carbon branches, right? CH3 branches. So if you break the ester, so what do you get? You're going to get, this side will turn into a carboxylic acid. It's going to form double bond O and OH. And this side will turn into a alcohol, and it will turn into a secondary alcohol because the OH will come on the middle of the carbon. So the alcohol is going to be at the middle of the carbon chain. So two carbon chains attached to this carbon, that's a secondary alcohol. So this alcohol is going to be, it's going to be B. Is this clear?
Yes, sir.
Yes.
Achha, next one is, let's move to the next one. Okay. Achha, now next one is, okay, you've got, sorry, this one. Now compound Y is treated with a single reagent under suitable conditions, 2-methyl butanoic acid is produced. What could be compound Y? So you're producing butanoic acid, that's but, and 2-methyl. So on the second one, there's a methyl. So what could be compound Y? So which molecule produces carboxylic acids? Carboxylic acids can be produced, if you look at the chart again, carboxylic acids can be produced by oxidation of an alcohol, a primary alcohol, or an aldehyde. So primary alcohol will get oxidized to an aldehyde, it will get oxidized to a carboxylic acid. So it's either a primary alcohol or an aldehyde that will turn into a carboxylic acid, or it could be a nitrile. A nitrile can be hydrolyzed and it will turn into a carboxylic acid as well. So either of the two. So if you have a look, a ketone is off. A ketone is not an option because it doesn't get oxidized. Ye wala kar lete hain first one. Butane 2-ol. 2-ol means OH on the second one. 2-methyl means the methyl is also on the second one. Now this one is a tertiary alcohol. Tertiary alcohols don't get oxidized. They have, I mean, we're looking for a primary alcohol, so this is not going to work. C might work because it's 2-methyl butane nitrile. So butane nitrile is CN or 2-methyl. So there's a methyl on the second one. So what happens if you hydrolyze it? The CN will turn into a carboxylic acid. So that's, I mean, that's, C is fine because you're going to get exactly the same thing. The CN will turn into a carboxylic acid. That's what's going to happen. TK, clear?
Yes.
Yes, sir.
I said, then you have the diagram shows the structure of a compound formed by the reaction of HCN with a carbonyl compound X. Now this one is a cyanohydrin. When you have CN and OH on the same carbon atom, so basically it's this reaction. Okay, what's a cyanohydrin? It's this one. It's the one in the corner over here. Then when you have an aldehyde and ketone, the double bond O, CN and OH get attached to it. So previously you had a double bond O, and now what has happened is that CN and OH have gotten attached to it. So that's what a cyanohydrin is. And this is, you need to know the mechanism as well. What's the mechanism of this reaction? It's given over here. That this is known as nucleophilic addition. That if you have a serial bond O, the CN gets attached to the carbon because it's partial positive. It goes and bonds with it, and the oxygen at the top, it then forms and attaches itself to the H. It forms an alcohol. So coming back to the question, you've got this thing. So this is going to be, what is the mechanism of the reaction? That's nucleophilic addition. So it's going to be nucleophilic addition. So what was it before this happened? Before this happened, this carbon, I mean, the C4H9 was there. The CH3 was also there. Before this happened, this must have been, I mean, this carbon must have been a carbonyl group. The CN got attached to this carbon, which was positive. And the H+1 got attached to the oxygen, which was negative. This became an alcohol. This got attached to CN. So what kind of, so it's a ketone. It's in the middle of the chain. So the compound X is going to be a ketone and it's going to be D. TK, clear?
Yes, sir.
As I say, next one, you've got this molecule. Skeletal formula of 3 compounds are shown. Which compounds will give a positive 2,4-D in pH? Kiska test that 2,4-D in pH. 2,4-D in pH is just a test for identifying aldehyde and ketones. Is this part. Orange precipitate for ketones and aldehydes. 2,4-D in pH. So now, so the skeletal formula of the 3 compounds are shown. Which compounds will give a positive test with 2,4-D in pH? Aldehyde and ketone. So this one is an aldehyde, double bond O at the end of the chain. This one is not good. It's a carboxylic acid. This one is an ester. But if it's serial bond O and O in the middle of the chain, that's an ester. This one is a carboxylic acid because it's double bond O and OH. While this one happens to be an aldehyde. So this is the only one that's going to give a positive test. So it's going to be R only. Okay, so remember, this one, it's only for aldehyde and ketones, 2,4-D in pH, not for any other thing. So coming back. Next one is ethanol gets oxidized by potassium dichromate 6, forms ethanol, it forms an aldehyde. Ethanol reactions, which statement about these reactions are correct? So the formation of both ethanol and sodium ethoxide are redox reactions. So is that true or not? The first one is true because that is oxidation. The potassium dichromate 6 is oxidation. It's a primary alcohol and it turns into an aldehyde. It's this reaction over here. So primary alcohol turning into an aldehyde. So what happens when you add sodium to it? Sodium is added to it. The H is lost and turns into hydrogen and it becomes O-1 Na+1. So this is what happens. That you had an alcohol and now that alcohol is going to be, instead of OH, it's going to be O-1 Na+1 and the H is going to be lost. So it is a redox reaction because the H oxidation state has changed. Hydrogen, I mean, whenever you lose hydrogen, that's oxidation. The H has turned into, its oxidation state is now 0. So its oxidation state is changing. Remember, whenever you have a metal plus acid reaction, it is a redox reaction because the sodium over here has also turned into Na+1. So this one over here is a redox reaction, this reaction over here. Okay, sodium has turned into sodium +1, so that is a redox reaction. You clear?
Yes, sir.
So A is correct. I mean, this one was, just remember in organic chemistry, a lot of your reactions are actually redox reactions. You just don't study them as redox reactions because, I mean, these are typical redox reactions where you have primary alcohols turning into aldehydes, aldehydes turning into carboxylic acids. And you've got typical reduction reactions as well. But a lot of other reactions are also redox. You have to keep your eyes open for them, although they're not studied as redox, but they are actually redox. I mean, metal plus acid, salt plus H2, you've never actually studied it as a redox reaction, but that's a redox reaction. Whenever there's an oxidation state changing, whenever there's Na turning into Na plus 1, that is a redox reaction. As the next one, 24. This one is, what is this? It's a mixture of ethanol and methanol are burned in oxygen to produce 35 cm cube of CO2 and 55 cm cube of H2O. Complete combustion occurs and the volumes of both products are measured at 120 degrees. So both of them are gases. So over here, the reason 120 is important is because water is a gas and carbon dioxide is also a gas. So you're going to treat them as gases. So what is the molar ratio of ethanol and methanol in the mixture? So how do you do this? It's 35 cm cube of carbon dioxide and 55 cm cube of H2O. So remember, for gases, and can you just hold on 1 second? So hello, can you hear me now?
Yes, sir.
Yes, sir.
Achha, this one. For gases now, okay, remember gases, mole ratio and volume ratio is exactly the same. So what is 35 cm cube ratio, 55 cm cube? Like in what ratio are the two gases? What's the whole number ratio? It's 35, 55. That's like 7 to 11, right? And remember, you're treating water as a gas. 7 to 11 is the same ratio as 35 to 55, right? Is that true?
Yes.
Yes.
So a problem is how do you solve this? It's saying what is the molar ratio of ethanol and methanol in the mixture. So basically, which mixture is going to produce carbon dioxide and water in this ratio? I mean, there's only one way of I can think of doing this question, and that is trial and error. It's like I can start with the first one. Like if I have one methanol, which is CH3OH, and I've got three ethanol to methanol mixture. So ethanol comes first. Just a second. So I guess there's no shortcut to it. It's just trial and error. You have so ethanol C2H5OH, and the other one is methanol. CH3OH. 1:3. Better the burn karo, simple burn. Burning of the. Actually, it's easier because you just have to make one equation. It's going to produce carbon dioxide and water, and the other one is also going to do exactly the same. It's going to produce oxygen, and carbon dioxide will be produced, and water is going to be produced, and you can balance them. So kind of easy because the equations are exactly the same. So 2 carbon dioxides, and there would be 3 water molecules, and this one, the other reaction will produce 1 carbon dioxide, and it's going to produce 2 water molecules. So if I have 1 of these and 3 of these, तो ये दोनों किस ratio में produce होंगे? If I have 1 methanol, it's going to produce 2 carbon dioxide and 3 water. If I have 3 of these, it's going to produce 3 carbon dioxide. So I'm going to get what? 5 carbon dioxides. And if I have 3 of methanol, it's going to produce 6 water. 6 plus 3, that's 9 water molecules, right? So is the idea clear that you're not getting the same ratio? So but is the idea clear how you're going to solve the question?
Yes, sir.
Sir, could you repeat that?
मतलब ये देखो ना कि उससे क्या ethanol and methanol are burning, right? So I know that ethanol burns and produces 2 carbon dioxides and 3 water molecules. Methanol burns and produces 1 carbon dioxide and 2 water molecules. 4 H's, so it's going to produce 2 water molecules. So in what ratio do they burn? So first one, 1:3. If there's 1 of this and 3 of these, right? 3 ka matlab hai everything gets multiplied by 3, right? So how much carbon dioxide will you get? You'll get 2 carbon dioxide from the first one, or agar 3 ye honge, so you'll get 3 carbon dioxides from the second one. So that's 5 carbon dioxides. If there's 1 of this, there's going to be 3 water molecules, and if there are 3 of these, there's going to be 6 water molecules produced. So 3 plus 6 kitna ho gaya? 9 water molecules. So is this idea clear? That you'll get in total, agar wo 1:3 hai, you'll get 5 carbon dioxides and 9 water molecules. Is that part clear?
Yes, sir. Yes, sir.
Yes, sir.
So that's wrong because our ratio is 7:11. Okay, so we'll now do the other one. 1:3 is not the right one. Okay, so let's redo this second option. So what's the second option? 2:3. So 2 of these and 3 of this. So 4 carbon dioxides in the first one and 3, so that's 7 aage. Okay, so sorry. I said we've got 7 carbon dioxides. I said 2 of the first 2 multiplied by 2, so it's going to be 6 water, and this multiplied by this will also be 6. So I'm getting 12 water molecules. So again, that's not the right ratio. So that's not the right one. So let's do the third one. Third one is 3:2. So that's 6 plus 2, 8 carbon dioxides. So I guess two carbon dioxides here, 6 in the first one. So I think that's also going to be wrong. As a 3:1. 3 ethanol, 1 of this. So 6 plus 1 over here, 7. Well, I guess 7, we've got 7, right? And 3 into 3, that's 9 water molecules, and 2 water molecules over here, that's 11. So that's also true. So D is correct. Is that clear? D is correct.
Yes, sir.
Yes.
So this was slightly tricky. Okay. Next one. Halogenoalkanes react with nucleophiles such as OH. Which pair of halogenoalkanes both react via an SN1 mechanism? So which particular reaction is this one? This one is again which are okay. This one is, it's this one. Halogenoalkanes are going to produce alcohols. The halogen is going to be substituted by OH minus 1, and it's an SN1 SN2 reaction. So it's going to get substituted by OH, and it will eventually turn into an alcohol. So how do you get an alcohol? What are the mechanisms? The mechanisms were these. There's the mechanisms given. So you've got 2 types of reactions. He's talking about SN1 mechanism. In SN1 mechanism, basically the Cl is going to get substituted by OH ions. So it will turn into an alcohol. What happens is that you have a tertiary halogenoalkane, and if you have a tertiary halogenoalkane, the Cl gets knocked out first. When the Cl is lost, a carbocation is formed, and the OH minus 1 comes in and joins with it, and it's a 2-step reaction. So you get a tertiary alcohol. So basically, SN1 is for a tertiary halogenoalkane. So we're looking for a tertiary halogenoalkane. So who's a tertiary halogenoalkane? So the first one is correct. This one is a tertiary halogenoalkane. This one is also a tertiary. Option A correct. Okay. He said both via an SN1 mechanism. Both should be tertiary halogenoalkanes. So the OH, Br and Cl will be lost, and OH minus 1 is going to take its place. This one is a secondary. This one is a primary. Primary ka mechanism दूसरा होता है, that's SN2. These are both primary halogenoalkanes. This one is tertiary, this one is primary. So A is the right option. Is this clear, this A?
Yes, sir.
I said then you have the next one, which is I guess electrophilic addition. What is the correct mechanism for the addition of hydrogen bromide to ethene? So it's this that I think it's this one. Positive H gets attracted to the double bond. So double bond electrons, they get attracted to the positive H, and the electrons over here, they get repelled. And the positive H takes away electrons from the double bond, bonds with it, and a carbocation is formed. And that carbocation would then get attached to Br-1, and it's going to be B. Okay. So again, this is just remember, organic chemistry is just these 4 pages. Okay, remember this. This is given HBr. Okay, the mechanism of electrophilic addition. Okay, just remember these 4 pages, the mechanism. Okay, you just had to answer this. Up 21. 2 carbon-containing products result from the reaction of alkene Z with hot concentrated potassium magnate 7. One product forms an orange precipitate with 2,4-DNPs. The other one produces. So one of the product 2,4-DNPs, that's an aldehyde or a ketone, right? So either an aldehyde or a ketone. The other product gives a white precipitate with calcium hydroxide, lime water. This is the test for carbon dioxide. Okay, calcium hydroxide is a test for carbon dioxide. So which alkene could be alkene Z? So this is what happens when, again, look at the chart. Okay, you have an alkene. There is strong oxidation that's happening. So you've got an alkene, the double bond breaks. That's the first thing. And when the double bond breaks, you got 3 options. It's either going to turn into a ketone. Like if it turns into a ketone, it has to have the double bonded carbon must have 2 carbon chains attached to it. Only then will it turn into an alkene. The second option is that it will turn into a carbon dioxide as well if it's got 2 H's attached to it. So we've got this scenario. He's saying that, and the third scenario is that it turns into a carboxylic acid where it's got 1 carbon chain and 1 H. So we're looking at these 2 scenarios because he said that 2,4-DNPS test was positive, so it must be a ketone. So the double bonded carbon must be bonded to 2 carbon chains. And it also turned into carbon dioxide because lime water, calcium hydroxide, you got a positive test. It turned milky. So white precipitate was formed. So that means the double bonded carbon atom must be bonded to 2 H's. So on one side, it must be bonded to 2 H's. On one side, it must be bonded to 2 carbon chains. So you're looking at an alkene similar to this. So which alkene could this be? I think it's going to be B, because if you look at propene and 2-methyl, this will have 3 H's. This will have 3 H's as well. This one will have. So this is exactly the alkene that we are looking for because the double bond will break. One of the carbon has 2 H's attached to it. So it will turn into carbon dioxide. While the other carbon has 2 carbon chains that are attached to it. So that will turn into is going to turn into a ketone. So it's definitely going to be B. Or is this clear, this one?
Yes, sir.
Yes, sir.
And remember, it was hot concentrated KMnO4, so this was strong oxidation. Now the next one is, which compound shows stereoisomerism? So stereo means either cis-trans or optical. So 2-methyl butene, But is 4, 2-ene means double bond on the second one. Second pair 2-methyl is this one. It's not going to form cis-trans because for a cis-trans, you need a double bond and you need both sides to be different. So that is not going to happen over here. So it's not going to form cis-trans. Second one is propan 1-ol. Prop is this thing, 3 carbon atoms. 1-ol means OH on the first and 2-chloro. Now, obviously, there's no double bond, so it's not about cis-trans, but it will show optical isomerism because is this molecule chiral? Is there a carbon atom which is bonded to 4 different groups?
Yes, sir. The one in the middle.
The one in the middle, okay, that's bonded to 4 different groups. So you got a CH2OH, you got an H, you got a Cl, you got a CH3. So this one is fine. It's going to form optical isomerism. So stereo is both. It's cis trans as well as optical. And the other one is difluorochlorobromomethane. So it's basically methane. 1 carbon atom. Difluoro means 2 fluorines. Chlorobromo means chloro and bromo as well. So again, it's not going to be chiral because it's not all 4 sides are different. Anyways, pent-1-ene is also not going to form cis trans because 2 of the carbons will have H's. So we're going to end it here. This one is note down kar lo. So we did questions 20 to 40 in this one. Let's continue next time. Okay, Hafiz.
Sir, is it May, June?
I mean, it's this one. This is S21 QP13. This one.
Okay. And sir, for the mind map that you have right now. Sir, do you mind if you share, because I tried to search in the website, I couldn't find it.
Which one?
Sir, the mind map for the organic reactions.
I think I'll share those. I'll share those. It's definitely there, but I'll share it.
Okay, sir, thank you.
Okay.